Swayam Prabha. Digital India. Educated India.
So I was telling you about combustion of fuel, right? Fuel also, there are new types of fuels which are of interest to many industries, especially aviation industry. So aviation industry now uses, or at least attempting to use, the fuel known as sustainable aviation fuel. The name is sustainable, means it can be produced again and again by repeating a reaction that happens in nature. For example, this Jatroba or Pungamia is, right, that this grows in Tamil Nadu a lot. Jatroba also goes Tenkasi area, Western Ghats area, okay, right. So this was used in the first commercial flight, that was KLM Boeing, which flew on 29/6/2011 with 171 passengers from Amsterdam to Paris. So there are attempts to somehow, since we as industrialized societies, we are so dependent on fuel, is it possible to produce fuel from a sustainable source, so that permanently there will be supply of fuel, okay. Actually, this word sustainable, permanently fuel is available, is an oxymoron, okay. Oxymoron means it contradicts nature, it contradicts thermodynamics philosophies, okay. It is not possible if you to continuously take carbon, burn it, and then produce carbon back fast, okay. If this path is very fast and this path is slow, eventually you have to have something here to make it fast, no? Right? And this is something people never ever talk about it. So that thermodynamics helps you to understand that this thing actually is just a fancy example, okay. It is not possible. Nature will not, when you ask it to do, or kuttikaranam podum, nature ungalku kuttikaranam podadu. Koranga dhaan podum. Nature kuttikaranam podumna, you have to wait for its term, okay. But the whole time without that it will not do. So anyway, these are all fancy topics. You should know that these things do exist. And methane gas, I told you about the Otto engine, right? In the Otto engine, compressed natural gas is used, of which 60 to 90% is methane gas. Rest already is the mixture I told you. It burns to give carbon dioxide gas and water in the form of vapor or gas. The heat of combustion is around 55,500 kilojoule per kilogram of methane gas. You go tell an auto driver, he could care less whether it is 55,500 or 5 kilojoule per kilogram. All he will say is, எவ்வளோ கொடுக்குது வண்டி, உனக்கு 60 கொடுக்குதா, எனக்கு 50 தான் கொடுக்குது, எங்கள் ஊருக்காரனை வந்து சண்டை போட போகிறேன் அப்படின்னு இல்லையா. அதுதான் அவங்களுக்கு what they want to know is what will the fuel per kilogram is cost money. How much money, how many kilometers it will give me, that is all they are interested. So, but we can calculate that also. What would be the theoretical maximum energy that can be extracted to do useful work from 1 kilogram of methane gas, we can actually calculate, okay. So, what does chemical thermodynamics help you understand in this? It will tell you, will the reaction as written proceed in the direction at normal temperature and pressure? That is what we call spontaneous. Normal temperature, that is not today just 37 degrees or 30 degrees or whatever, 1 atmosphere pressure. Will this reaction take place without any external intervention? No external intervention. So that is called spontaneity. Is this reaction spontaneous? That thermodynamics, chemical thermodynamics will tell you. It will also tell you to what extent this will take place at normal temperature and pressure. So I mix methane gas along with air at normal temperature and pressure. Chemical thermodynamic principles will tell you in the reaction mixture after some time, that sometime we don't know how much time that sometime is, because chemical thermodynamics doesn't worry about time, it worries only about end result, okay. So how much of carbon dioxide will be there, how much of water will be there, how much of unreacted methane gas and oxygen will be present. That thermodynamics will tell you. Tell the temperature and pressure, it will tell you this much of methane gas would have burnt at room temperature and 1 atmosphere pressure. But if you want all the methane to burn, it will also tell you what is the temperature you should use. What should be the pressure? What should be the catalyst? It cannot tell. Thermodynamics cannot predict. That is where we have to find out catalysts that will actually make this happen. Thermodynamics cannot predict which catalyst will give what. Okay. So, can we change the extent of reaction? That is some very important in this case, in a combustion, that thermodynamics can predict. And what will be the maximum energy that can be extracted as useful work? If I use 1 kilogram of fuel, what can be the maximum limit I can extract out of that? That can be predicted by chemical thermodynamics. So, now I am going to come with an example, and before I come with an example, what are other modern topics, contemporary topics? Green hydrogen is considered as a good fuel. I will give you an example. This, I don't know how many of you read in newspaper, our railway minister Ashwini Vaishnav, he came to Chennai about 2 months back, and then he said that from our rail factory in Perambur, ICF, he said that we are going to shortly test hydrogen fueled engine of 1200 horsepower running on hydrogen fuel, built by Research, Design and Standards Organization, Lucknow. An initial trial is planned between Jind and Sonipat, distance is 89 km. Maximum speed that can be obtained is about 110 km theoretical per hour is what they are trying, and the reaction or relevance is water liquid becoming hydrogen gas and of oxygen gas, but in the rail the reverse reaction will take place. So, green hydrogen is hydrogen produced from green energy. Hydrogen is hydrogen. Now we have many names given for hydrogen: green hydrogen, brown hydrogen, black hydrogen. Okay. So, if you produce hydrogen by unsustainable method, it is called black hydrogen. If you produce it by steam cracking, it is called brown hydrogen. Green means it is free, nothing is free. Green hydrogen means you produce hydrogen by using either wind energy or solar energy. But solar energy, can it come free? Wind energy, can it come with free? You have to install, no? You have to put blades, everything. But anyhow, that is a terminology that green hydrogen is produced by using wind energy and solar energy, right? So, if suppose you make a lot of hydrogen by green energy, that can be used to run a rail, and this is, I think, going to be the first train in India where hydrogen produced by green method will be used as a fuel in a fuel cell. So, reaction will be hydrogen combining with air to give water, and that is a highly exothermic reaction, will give a lot of energy that can be used to run the engine, and the only product of combustion will be water. So, in place like dry states where there is no water, maybe you can run the railway engine, and back you can put a lot of buckets and collect water, which is the product of the reaction, use it for agriculture, drinking and whatnot, because that is the purest form of water. So, green hydrogen is something that is a fuel that is being talked about now, and green hydrogen is produced by this reaction. And again, here chemical thermodynamics can tell you under normal temperature and pressure what will be the concentration of hydrogen gas present, oxygen gas present, and what should be the variable that you should change here. Variable is this: pressure, volume, temperature, concentration. Catalyst to make it produce more hydrogen gas and more oxygen gas. During COVID time, there was desperation to generate oxygen, in situ oxygen for hospitals. Okay. So, oxygen is extremely important in hospitals, where it is okay in a hospital to use water, use electricity and generate oxygen because life saving. Okay, I am not so sure about using hydrogen to run an engine, because you have to still spend money to make that hydrogen, and invariably thermodynamics will tell you straight away that whenever you produce from water hydrogen gas, say let us say you spend 100 rupees of money, when you make from hydrogen gas water and run a engine, the cost will be much more than that. So there is no point in producing. Basic thermodynamics, chemical thermodynamics will tell you, don't try to do stupid things. But then there are reasons why people do stupid things, okay? For some reason, because it's the most state-of-the-art technology. I want to be better than China, I want to be better than that country, this country. There is no good reason. If you violate the laws of thermodynamics, you will be fooling yourself. But many countries do that. Many people do that, and you will see this, in due course of time. Fuel cell is a setup. It is a setup where what happens is hydrogen is mixed with oxygen or air to make water. So anodic reaction is hydrogen gas reacts with the O2 minus to make water in the anode, and in the cathode O2 is oxidized to give 2 O2 minus, and the overall reaction produces 1.2 volts. That is a reversible potential, but not really, it will be always be less than the theoretical maximum one can expect. The advantage of a fuel cell is that the energy efficiency of a hydrogen fuel cell is 50 to 75%, whereas an IC engine operates only at about 20 to 25% efficiency. The advantage is what makes people go for this technology, okay? And fuel, so we just said on fuel, I gave you several examples. One is the aviation, sustainable aviation fuel. Other thing I talked to you about is green hydrogen, okay? Now, on the same, our second topic is energy storage. So you need to have a mechanism by which energy that is produced is stored in a chemical system. Energy invariably, the only mechanism available for storing energy is chemical systems. Without chemical systems, energy cannot be stored. You can use energy that is produced by instantaneous. For example, light burning during daytime, that is solar energy. You can use the energy from solar, that is light to electricity to light. That is, during daytime you can produce light. You can make AC work during daytime. You can make vehicles run, fridge run at daytime, but night time you can't do anything. So is wind. Whenever wind is available, you can generate energy. When wind is not available, what will you do? Can you use like that? I want to turn on AC for 5 minutes till, or when the wind is outside, I want to have AC, and wind is out, AC will automatically turn off, right? But you need energy continuously, and one way or only way available in nature is to chemically store it. There is no other way available other than storing energy chemically. There are other inefficient ways of doing it, but efficient way is always to convert it, take the energy, put it in the form of chemical bonds, and when you need it, release it. That is the only way known to humankind. There are other trivial methods known, but I don't want to discuss that. Okay, so this energy storage is very important for electrical vehicles, because battery technology is what runs today's EVs. Okay, without a proper battery technology, you will not have EVs running, right? So there are a number of batteries, out of which an important one is zinc air battery. Zinc air battery is an example of a primary cell. Okay, primary cell means it is non-rechargeable. Secondary cell means it is rechargeable. Okay, so primary cell, overall chemical reaction is zinc solid reacting with oxygen gas to give 2 zinc oxide. The potential is 1.59 volts, and the global reserve of zinc is estimated to be about 2 billion tons. With a very high specific energy density of 400 milliwatt hours per gram, this battery is awaiting commercialization. Still not been commercialized, but this will be a useful battery to commercialize. And the free energy that one can get to do useful work from this battery is NF minus NF E naught. So minus 2 electron transfer here, F is 96,500 coulombs, potential is 1.59 volts. So this much of energy, 306,870 joules, would be available to do work according to Gibbs free energy. Okay, so this zinc air battery is a classical example of a reaction of interest that I told you. We are going to deal with some modern examples. A typical Tesla Model 3 car is equipped with a 75 kilowatt hour rechargeable battery. Okay, that involves 4,416 individual cells or secondary cells put together. and the range is 600 kilometers per charge. So the positive electrode in such lithium rechargeable batteries, lithium COO2, now it is lithium FePO4. The negative electrode is invariably graphitic carbon, and the liquid electrolyte is what is being used till today, but a promising flame resistant solid polymer electrolyte is likely to emerge very soon, whereby you will have no risk of fire. Okay. So this is another case. Rechargeable batteries is another case where there is room to study this. So some of the chemical reaction of contemporary importance I presented to you. Before we study the application of chemical thermodynamics to chemical reactions, so an example from day-to-day experience may help in better understanding. Now whatever I told you, everything will make sense only when you are able to appreciate it from what you know. You are saying you are able to appreciate it from what you know from day-to-day experience. Okay. So what is day-to-day experience? Suppose you want to buy a mobile phone. Okay. Chemical thermodynamics is nothing but equivalent to this example. I am going to give you a simple example. Okay. Suppose you want to buy a mobile phone and you are interested in Apple iPhone 16. That is the latest model. You can buy it in India for about 80,000 rupees. 80,000 plus little more, but 80,000 you can easily buy. A little more than that. Okay. So this would cost you money, no? To buy a phone, you need money. Where will the money come from? Father, forefather, grandfather. If they have lots of money, or you have plenty of land, houses to build, sell and make money, then you can buy lots of iPhones. Otherwise, you have to earn this money, no? Right? This would cost you money for the purchase of mobile, and you have to also pay service charges. No mobile manufacturer will ever sell a phone. No car manufacturer will ever sell a car. No refrigerator maker will sell the refrigerator. It is always sent through a distributor. No farmer will ever sell a produce. Farmers don't know how to sell produce also. It is always sold by a middle person. Okay, they know how the market works. So it will cost you money for the purchase of the mobile, and you have to pay a service charge, right, to the distributor. And when this happens, the government is looking over your shoulder. Any transaction, when I breathe, GST, no. Government wants GST on breathing, breathe out, dead body, human body created everything, because government works like that. It needs to generate money for anything and everything, right? So this is exactly what before you take any task, you have to calculate all factors. How much of money will go to the landlord? How much of money I have to pay off the, record? Electricity charge for Tamil Nadu government is 4 rupees per unit, but landlord will say 10 rupees. He will make 6 rupees per unit electricity. All these things happen, no? So before you rent a house to stay in a place, you have to calculate everything. What is this area? Where is the nearest milk shop? Where is the nearest vegetable vendor? Where is the nearest school? Like that. Same thing you have to do in the case of chemical, nothing else other than that, right? So after you purchase the mobile, cost of iPhone I put 80,000, maybe it's more. GST is 25%, it may be even more, I don't know. Just simply I put a figure, okay, 20,000. The cost to you will be 1 lakh, okay. But if you look at the breakdown, mobile manufacturer will get only 90% of the cost of the mobile, 72,000 rupees. Revenue to distributor will be 10%. What he will do is to attract you, he will cut down his commission. Car sellers do that, two-wheeler sellers do that. Anybody who sells, distributor will always try to pass on his commission so that he can attract you, right? So that is the money. GST, nothing. Can you reduce it by 5%? No, I can only increase it. GST will always be on bread, butter, patani, everything they will, sundal, everything they will put GST, okay? So that is how it runs. The system is like that. I am not trying to blame anybody. I am trying to tell you that whenever there is any transaction, the government is watching. Give me my money. What did you do? Did you give me good roads? Did you give me good sustained electricity? No. What I give or not, give me my money. Give me my contribution. So people want to somehow cheat the government so that they can give minimum to the government and pocket the money. People are also very clever. They cheat on everything. Okay, the government alone is the culprit. People are also equally culprit, right? So overall total. So this is what, before you go iPhone, you have to make sure you have money. Right? You have to have money in either you earn the money or go fight with your father or mother or do something and get the money, okay. And you know that the bill will tell you who is getting this part of the money, who is going to get what fraction. Exactly the same thing happens in chemical thermodynamics, okay, exactly the same thing, okay. So this reaction I told you already, methane gas reacting will give you 55,500 kilojoule per gram. Methane doesn't know any trick. With oxygen you burn it, it will give you 55,500 kilojoules for 1 kilogram. Nothing, not even 1 joule less it will give you, okay. But what happens to the auto driver? You see, now this is a real example. So 1 kilogram of methane gas has been used to move the auto roughly 200 kilogram. Okay, rough weight, don't go by the exact weight. You have to go check the side of the auto where there will be exact mass of the auto, because every year they have to get RTI, RTO certification. Money, they have to pay money for that and get certification. Okay, so the RTO will take a lot of money, but he will tell the exact mass of the dead mass of the auto plus driver mass plus mass of the person sitting in the auto. Okay, so I am put whole thing as 200 kilogram. Okay, so net result is auto moved a distance of 20 kilometer using 1 kilogram. The auto driver knows 1 kilogram of methane gas will give me 20 kilometers. Okay, so what is work? What is work? Work is when force acts over a distance. Very simple. F equal to ma. Force acts F equal to ma. When it acts over a distance L, MAL will become the total work done, right? So 200 kilogram, auto has moved a distance of 20 kilometer, and what is the gravitational force which is pulling the auto down? 9.8. So auto which moved a distance of 20 kilometer is 20,000 meters. The work done by the auto physically moving it 20 kilometer is 39,200 kilojoules. 1 kilogram of methane gas which gave away 55,500 kilojoules of energy actually has done only effective work is 39,200 kilojoule. What happened to the rest? This is what thermodynamics is. Okay, in our language, okay, so what happens is rest goes away in various types of losses. Okay, the general way we say that is entropy. Okay, gone. If I give you 100 rupees and tell you deposit in my State Bank of India account, I give you account number and I find that you deposit only 90 rupees, 10 rupees is entropy. 10 rupees is lost to you. I asked you to deposit 100 rupees. So fuel, any chemical that is used, when it bonds are broken and generates energy, everything cannot be converted to work. Something it itself will eat. Okay, to make it fly faster, increase its entropy, some energy will be taken away by the fuel itself. Okay, in addition frictional loss and many other losses. Okay, so what thermodynamics does is just gives you balance sheet, simply tells you balance sheet. 1 kilogram of octane should have given in principle this much of energy and the auto should have moved this much of distance, but auto has moved only this much. What is the reason? Where are the losses? Loss is driver did not follow the speed limit, road condition was bad, government took tax, did not make a good road, tires are bad condition, did not maintain the tires properly, moving parts were not lubricated properly. So everything you optimize, and I am going to tell you these are the factors we are going to see in all chemical and physical transformation. Where exactly is this energy going? Where exactly it's being lost? One of the things that we say is entropy. Very broadly we say that when this is the amount of energy that is not available at all, it will be simply that you have to give to the nature, to the surrounding, to the universe. When I want to move from here to here, if the energy is 10 joules, I have to give 2 joules to Mother Earth, to surrounding. Otherwise it will not allow me to move. 10 joules I can never do work. That is the fundamental principle in the chemical thermodynamics. With this example, you are going to appreciate it. Okay, so I am going to tell you principles. Now, the principles will tell you where exactly you can figure out where exactly is what is happening. Okay, so this having done this, so chemical thermodynamics, what it tries to do is it answers whether what would be the natural direction of a chemical reaction as written? Some reaction I write, will it go in the forward direction or backward direction? If so, at what temperature? Okay. At normal temperature and pressure, will it go in the forward direction or will it go in the backward direction? What is spontaneous? At normal temperature of, say now, water vapor which is present in the atmosphere. So, will it condense or will it remain as vapor? It depends on the time of the day, right? Early morning and night time, water vapor will prefer to condense. That you can very easily figure out by taking a glass plate, rub it nicely and keep it outside. If it is early morning and night, you will see small deposition. Daytime will vanish. So what is the idea is, what would be the natural direction of a chemical or physical process at normal temperature and pressure? And what would be the extent of that? How to vary the extent of the reaction using variables such as this PVT? What would be the maximum energy that can be gained as work from a spontaneous reaction? What would be the minimum energy required to push a non-spontaneous reaction to take place? What is a non-spontaneous reaction example? Hydrogen water liquid becoming hydrogen gas, green hydrogen gas. It's a non-spontaneous reaction. What is the minimum energy I have to place before I can get hydrogen gas? That can be figured out. It is not 1.2 volt. Hydrogen gas plus half oxygen give H2O. The reversible potential is 1.2 volts. At 1.2 volt, you will never be able to electrolyze water. You need to put little extra. And the reasons, thermodynamics reasons out, tells you these are the reasons why you need to really give a little bit extra. Otherwise, everywhere to move the system, starting from the peon all the way to the collector, you have to pay. Otherwise, system will never move. Salary is extra. Okay. Salary is extra. 30 days of living in the world, you get salary in the government with government service. Actually, what is the real lubrication? You have to start from the peon all the way to the collector, to the minister. What you give is the extra factors. And all these factors for a chemical reaction, you can really find out, oh, this is the money to be given to oxygen. This is the money to be given to methane. This is the entropy or energy to be given to carbon dioxide. Otherwise, carbon dioxide is not happy. Where are the, எப்படி பாகம் பிரிக்கிறது, பங்கு பிரிக்கிறதுன்றது தான், that is the thing. Okay. So, what does it require? It requires the following inputs. You should know what is the nature of the system. Open system or closed system or isolated, ruled out. Mostly closed system. Okay. What is the state of the system? Does it contain gas, liquid, solid or mixture? Okay. Gas means it will take a lot of entropy. Solid will not, the entropy will not be that much. Okay. What are the variables which we saw here? What is the process to be followed? So far I didn't discuss any process. All transformations, physical or chemical, they invariably take place at some temperature or pressure. Invariably it takes place at 1 atmosphere pressure. That is normal pressure. So most of the chemical transformations are isobaric. Okay, isobaric and closed system. These are normal. But sometimes it can be isothermal. You want the temperature to be constant, then you have to fix it. If you do a reaction at room temperature, it is isothermal. Okay. And isochoric, choric means volume. Isochoric, sometimes it can be isochoric. And other inputs are what is the amount of heat absorbed or given out, and whether there is any visible production of work, any boundary movement. If there is a gas, there will be a movement of the boundary. Okay, there is a gas. So liquid, solid, don't have to worry. So these are the inputs that you require, these inputs before you can come to some conclusion. Okay, what I have done is, so far I have given you a brief, very broad outlook. Okay, still not yet to touch the subject. Okay, I will touch the subject now, and whatever references I have taken is from P.W. Atkins figures. Some of the figures I have taken from P.W. Atkins, standard figures. Okay, and when I teach, I invariably use Gilbert-Castellan, because Gilbert-Castellan I find is a really good book from my point of view. Every teacher will have their own taste. Okay, my taste is Gilbert-Castellan and figures from P.W. Atkins. So far we have just managed to touch the broad outline. Okay, now we have 20 minutes. 20 minutes, First law I will quickly try to go through. Okay. First law you are already aware? Law of conservation of energy, right? So we'll just quickly walk through it, and if you have any doubt you can ask me so that we can, I don't want to just cover a topic for the sake of covering. If you are not happy, stop me. Tell me this is not clear. I'll be more than happy to clear it. Okay. So far recall states of matter are gas, liquid, solid. Variables that define a state. What is a state? A state of a system is defined by a state of a system invariably. This is the representation we will use. A state of a system, say let's say 1, let me write 1. Suppose I write a state 1 defined by an composition, right? For a closed system, you need not worry about the composition. This composition is fixed. Otherwise, you have to worry about it. Okay. So what I can do is state of a system. This is closed system. State of a system is defined by the state variables, which are pressure, volume, temperature. So when I take a system from state 1 to state 2, what will vary? Pressure, volume, temperature. Okay. So this is something that variables that define a state. And is it a real gas or ideal or perfect gas or real gas? I told you real gas makes everything very complicated. So in books, no matter which book it is, highest form of book, everything will be done with a perfect gas only. But remember, there is hardly anything which is perfect gas. Maybe helium, okay, at some temperature is a perfect gas. Most of the gases are non-perfect, but perfect gas law is more than adequate. So we will be dealing with gas law and process. This is the most important thing. When you take it from state 1 to state 2, there has to be a process, right? Without a process, how do you carry it from one place to another place, right? So there are two processes which are recognized. One is known as a reversible process, other is known as irreversible process. So reversible and irreversible process are two different ways of transferring a system, changing the state of a system. So here it is either reversible or irreversible. So A to B, reversible. For example, you take me. From 1961 to 2025, my growth, biological growth, could have been reversible or irreversible. Okay. But reversible process doesn't exist in practice. Reversible process exists only on paper. Why does it exist on paper? Because we want to know the theoretical limit. This limit can never be exceeded. So in order to fix the limit, we consider the reversible process, which exists only on paper. All real transformations are irreversible. Okay. So reversible process is recognized by the fact that any change in the system when it goes from state 1 to state 2, it can do only by infinitesimal steps. Okay. What do you mean by infinitesimal steps? So I start from P1. So I start from P1. Let me take, I am going to plot only two variables because the third variable I cannot plot in a graph like this. Third variable will require third dimension, right? So I am going to assume only P and B varies, keeping T constant, because otherwise graph cannot be drawn on paper. right? So I go from here state 1 and state 2 and say T is constant. So this initial state is known as P1, V1. This is P1, this is V1, and this is P2, V2. This you know how to do, right? Whenever we do in mathematics, we always say two variables represent a point on a Cartesian coordinate, two-dimensional coordinate, 2 points, x and y, right? So from here, P1 of higher pressure to P2 which is of lower pressure, we are going infinitesimally, reversibly, with simple steps. High pressure, low volume, low pressure, high volume. So this is known as an expansion process, isn't it? So this I can do infinitesimally. Infinitesimally means the change in pressure is dP, or volume change is dV against a constant pressure of P2. So the change is, this change is known as infinitesimal change, right? Tiny change in volume against a constant pressure of P2, external pressure of P2, and I do it tiny change. The tiny is so tiny that it is only mathematically definable, not in real term. So infinite number of steps are required before I can go from this one, P1, V1 to P2, V2. Infinite number of steps is required. So that is a reversible path. Okay, so that's a mathematical path. You can do only in paper, integrate only in paper, nothing exists in real. In real world, you will change the volume, just bang, that's all. Okay, nothing happens infinitely. So there are two, one is reversible process, other is irreversible. All real processes are irreversible. Reversible process only exists on paper, and that is only useful for finding the limits. You cannot get a number more than the reversible process. That is the reason why we have. So we know the limit. And then in this reversible and irreversible, reversible you forget it, I told you, for limits only. We know the limits, we want to know the limits, but nothing can be done about it because it doesn't happen in practice. Among the irreversible processes, there are these kinds which we already saw: isobaric, isochoric, isothermal, and adiabatic. Adiabatic means no heat transfer, Q equal to 0. Okay. So measurable properties, this is what happens in a system. What are the measurable properties? Suppose something happens to you, right? After this class you go out, Professor Anbarasan sees each and every one of your face. How will you figure out what happened in my class? You are not willing to reveal. You are not willing to reveal what happened in the last 2 hours. When you go out, Professor Anbarasan is waiting outside. So he is trying to, he'll figure out. No. How will you figure out? You are not telling anything. Oh sir, lecture was good. Okay sir, it was good. But from your face is a variable. Your face reading, you will read your face and says, their lip says lecture was good. Face says lecture is bad. So what are the two variables? Face reading, lip reading, isn't it? He is sensing it through his ears, eye. Same thing here. Okay. So when you need measurable properties of a system, or whenever you want to know something about a system, only way you can figure it out is what is a change in pressure, what is a change in volume, what is a change in temperature, is it absorbing heat, is it giving out heat, what is happening to the system, is it doing any work? That's the only way you can measure a system. So whatever we do, we try to relate to that, what we measure to find out what has actually happened in the system, chemical system or physical system, as the case, chemical system only. So now illustrative, this diagram I didn't draw, I took it from some source. I am not able to recall because drawing is not my strength. Okay. So I found this to be very useful. Somewhere I took it, but I am not able to recall the reference. So this is just given as an example. So these are PV diagrams like what I drew here, okay. Pressure on this axis, volume on this axis. And what we are going to talk about is a transfer of system from 10 atmosphere pressure, P is 10 atmosphere, initial volume is 2.24 liters to 1 atmosphere pressure, that is it is coming down to our normal atmosphere pressure from high atmospheric pressure, 22.4 liters. So there is a transformation of state from 1 to 2 and variables have changed. You can measure the, see the variables, there is a change in volume, 20 liter volume change roughly, and pressure has changed 10 times, right. So we want to see what can be the theoretical maximum work that you can get out of the expansion. If you want to find out, what you will do is P versus V, infinitesimal steps you have to do it. Expansion, theoretically, on paper, you hold the vessel and release it very slowly, the pressure on the vessel. Slowly do it very slowly until this happens, right. Continuously this change in pressure and volume happens. So the area under the curve is the work done, which is 10 atmosphere pressure multiplied by that integral PdV, right. So if it is one shot, if this work was done by a reversible process, it will be given by RT ln V2 by V1, and we are going to see this very soon because it's nothing but integral PdV, work done reversible, is given as integral PdV from volume 1 to volume 2. P is a constant, so we will take R by PV equal to RT, somewhere we wrote, no. So P equal to N equal to 1 mole, we will put 1 mole. So that will be RT dV by V, V1 to V2, which is nothing but RT ln V2 by V1. So the area under this curve is RT ln V2 by V1, or T is 25 degrees, 298 ln final volume by initial volume, which gives you as a number of 56.3 liter atmosphere, okay. That is the total work is 50, this for the reversible work, minus this work by reversible process. If it is expansion 56.3, if it is compression minus 56.3, this is the reversible work. But on the other hand, if it was an irreversible work, that is one shot expansion. What is one shot expansion? Starting from 2.24 liters in atmosphere to this by just simply releasing the whole thing, okay. If you do it in one shot, that means external pressure is P, 1 atmosphere, change in volume is 22.4 liters minus 2.24 is equal to 20.16 liter atmosphere, that is this area. So I start from here against this P, external atmosphere pressure, which is 1 atmosphere pressure, the net change in volume is 22.4 minus 2.24. So this is the area for one shot, just one shot expansion. The work is 20.16 liter atmosphere. If you have to do it in 2 shots, 2 shots means first you do it against this pressure, same 1 atmosphere, but only this volume, from this volume to this volume, and next you do in this volume to this volume. If you do it in a 2 shot expansion, total work done is this plus this, okay. If you do it in 3 shot, so if you do it multiple shots, you can see that 1 shot is 20 liter atmosphere, 2 shots is 28 L, 3 shots is minus 33, and infinite is 52. So what does it tell you? It tells you if you do in a non-practical manner an expansion job, if you allow a gas to expand in a non-practical manner, you can get maximum work. But that is non-practical. But if you do it in an irreversible process, if you do it in a 1 shot expansion, you get less expansion work. 2 shot expansion, which is practical, you will get little more energy, work. 3 short, a little more. So it's very important to notice that the reversible expansion or reversible compression, which doesn't exist in practice, and it gives you the area under the curve as the total work done either by the gas or on the gas. On the gas if it is compression, expansion it is by the gas. That is when you will get the maximum work, you will put minimum work in the compression case. So it is important to understand this fundamental concept that anything, any system, if you make it do work, you can extract the maximum work out of the system only when it happens in a very slow not time, stepwise, multiple steps. It has to be large number of steps, infinite number of steps before you can get maximum work out of any system. But that's number of steps. Who has the patience? You cannot have a bus going from here to T Nagar, right? Going inch by inch, row by row. If it goes inch by inch, you will reach when your life is done. By the time you are old, you will reach T Nagar, right? Everything has to be done. It has to be done at some speed, some rate, something has to be done. So this reversible work only fixes the limitation. If you are willing to be patient, if you are willing to go through large number of steps, then you can get maximum work out of any transformation. Any transformation of chemicals can get maximum work, positive work out of it only when you are willing to do it in small, tiny, infinite number of steps. All other real steps will always be less. Remember, this is only to fix the limits. It's not to teach. Reversible doesn't exist. Tell you the limit. And remember, if somebody fools you, telling that I got this mark out, right? It just simply cannot happen. You may remember the case of, I don't want to name the person, that somebody from Sankaran Koil, I think. He claimed to have discovered biodiesel. Okay. And many people were, especially MPs, there was a Congress MP from that region, was very unhappy because it came to IIT. IIT said not possible. Okay. From a plant seed, if you take a plant seed, if the mass of the seed is 10 grams, can you get all 10 grams of oil? Or even more than 10 grams of oil? From 10 grams you cannot get more than 10 grams, no. That was a claim. What we found out, simple mass balance we did. He added the seeds to some water and did the experiment and got more oil than mass of the seed. We asked him to weigh the seeds. Weigh the seeds. Then we said, weigh the oil. How did you get more oil than the seed? He immediately understood that he's a trickster. Okay. So he escaped, didn't tell anything. He was caught when he was doing the experiment here in IIT Madras. And he told his political bosses that these people are very harsh on me. They are not believing me. So all we did was, everything was videographed. We said 10 grams of seeds used is getting 20 grams of oil. Tell us, where did the oil, does the seed produce oil while it is being boiled? Where does that mass come from? If the seed is producing oil, where is that mass coming from? From air? It is going into the seed. So that we exposed. But there was some person who was behind it because they wanted to do some trick to earn money. Okay. That's a big political scandal. Then we exposed it. Our job is to look at it scientifically. So here also you look at it scientifically. This is the maximum work you can get. But such a thing cannot happen because it's not a practical process. In real process, you will always get less. How much less you are going to get and how much you are going to optimize. How many steps I can do it so that I can get the maximum work out of a transformation, like I told you, zinc air battery. How much maximum energy I can get by operating the zinc air battery under the right condition. Right? So this work is a fundamental concept from the first law of thermodynamics. Okay. The first law of thermodynamics has two components. The the total energy is constant. If you want to change the total energy of a system, you can do it only by two ways. One is use of heat. other is by doing work. That is the first law. Okay. So the first law tells you that U or delta U, change in internal energy, is brought about by heat component and work component. Any internal change, energy change, can happen only when you add heat or remove heat, add work or remove work. So liquid and solid, don't worry, because liquid and solid there is no change in volume. So work component will go away. Only internal energy changes, heat change. But gas alone there is a problem, because gas there is a constant change in volume. Gas will change volume. Okay, it is very sensitive to pressure and temperature. So this is the first law. And if it is gas, there is a limit that you can always, you have to be aware of this limit, and that limit is given by this particular graph. And I didn't draw this graph, I told you, I wish I had drawn this. So we are going to deal, I already told you we are going to deal only with closed systems, and I am just going to summarize. So a few minutes I will close up, okay. That you are probably familiar with the following terms. Zeroth law, already familiar with zeroth law? Okay. If a system A is in thermal equilibrium with B, and B is in thermal equilibrium with C, A is in thermal equilibrium with C. Simple, straightforward. And this is the first law. Okay. Delta U, the change in internal energy, written here. There is a heat term and there is a work term. Okay. So delta U is a change in internal energy. If you do it at constant pressure, dQp, heat absorbed under constant pressure, is nothing but enthalpy change, and it is given by NCP delta T. And if it is at constant volume, change in internal energy is dQv, heat absorbed under constant volume, and it is given by the term NCV delta T. This we already saw. Reversible process, work change is nRT ln V2 by V1, and for an irreversible process it is P external multiplied by delta V. So here I will stop, because I think I have already, next I have few slides to cover, but I will take in the next class. Okay. Already I am able to see you are tired. Okay. So I will leave you here. Few more slides, but next class I will start with the. So this part up to this, any clear? Any questions you have, you can ask me. Any question? If you have question, anything was not clear, I will be happy to stay back and explain. Anything that was not clear. Very important to understand this limits. Okay, that you remember that there is a limit. Non-experimental or not practical process fixes the limit. Okay, the reason why we do all this is to know the limit. Okay, any question you have? Anything specific? Next class we will ask. Okay. Next class you will ask. Maybe beginning. At the beginning of the class you will ask questions, so I can proceed. Are you aware of the state function? What is a state function? What is a path function, state function? You are aware. But what is state function, path function? Very fundamental concept like work. If there is anything, any understanding, you have to understand work. Reversible work, irreversible work. Very important to understand. Other thing to understand is what is state function and path function. Very important. Okay. You know that your grandfather and grandmother lived. You also know that they died. Right? Do you know exactly what transpired in their life? What were the things that they went through in their life? The only thing you know is they had lived and they died. That's for sure, otherwise we will not be there. Isn't it? Father, mother, and then we are. So what they go through in their life is not known, except it is buried and went with their DNA, that's all. Memory. That is a path function. They were born and died is state function. For all of us there is a state function. All of us will be born, all of us will die someday. That is a state function. Big deal. Very important fact. No? Path function is what life is all about. what I am going through today, this moment, 1 hour from now, if I get an ice cream to take after this class, I enjoy that moment, right? And that can never be translated anywhere. That is a path through which I have gone. 2 hours a lecture I have listened to, then I went and had an ice cream. You will remember, more than the thermodynamics, I remember the ice cream. Okay. So that is a path function, what you actually go through. State function is beginning, Adiyum Ni, Andamum Ni, and that's all okay. Between Adi and Andam, what do you do? Okay. That is path function. Okay. Beginning and end. A function whose value only depends on the initial state and final state, birth, death. That is state function. But path function is what actually happens. Okay. By 0th time, I moved from Nagapattinam to some place, then I moved to Chennai, then I moved to within Chennai so many places, then I went to USA, then I came back to this, then again to Delhi, this, that is my path. You have to summarize my life by taking all these factors into account, and then only my life is done. Born in Nagapattinam, died in Chennai. What is a big news? That is state function. Okay. Again, like reversible work, state functions are only that it's a function that only tells very little about the system. You need to know more about the system by path function. State function is again a theoretical limits you have in order to understand the real thing that goes on in a system. It's another. So state function is something you should know. Reversible, irreversible. And all the 3 laws of thermodynamics, which are we have to take for granted as 3 karanams why things happen in the universe. We have to take it as a fact, because this is not part of chemical thermodynamics, that's part of the physics thermodynamics. Okay. So we'll stop here.
SwayamPrabha. Digital India. Educated India.